Theory of knowledge connection. If imaginary numbers don't actually exist in the real world, complex numbers are formed using imaginary numbers. Can complex numbers be said to exist? Well, I could also say that negative numbers don't actually exist. I owe you $20. We would probably say as I have negative 20, but can I physically represent negative 20? Numbers are a abstract representation of things. The name imaginary numbers might be an unfortunate name because they're just as real as some real numbers. Um, so on the flip side, if complex numbers do exist in the real world, as demonstrated, do they by proxy prove the existence of imaginary numbers? I would say yes. This calls into question the accuracy of the deduction and the role of perception of existence. A common question that emerges is the application of deductive logic sufficient to establish truth? That is a very good question. We like to think there is complex solutions to quadratic equations. Okay, you've done this. You know the quadratic formula.
So this point.
Find the solutions to this. X equals negative b. Okay, so negative b would be 5 plus or minus
Square
25.
is 4, 1, 6.
This isn't even a complex number.
So
2 times 1. I always write the times 1 because I forget it too often when it's not.
it squared. Otherwise, I square it twice.
Oh, okay.
Like I've done that before. It really messed me up.
So 5 plus or minus 1 over 2. 6 over 2, which is 3, or 4 over 2, 3 or 2.
Skip steps. You forget what you already did.
Yes. I will often square the b as I plug it in. You know this thing called the determinant?
Isn't that the middle?
That's the b squared minus 4ac.
But yeah, it's not the middle, but it's just square
It's the
root.
root part. You should know that when that's negative, you get complex numbers. When it's 0, you get a single solution.
Minus 4 is.
Or, well, yeah, but a lot of times C is negative. And that's how we get that. When it's positive, you've got 2 solutions. When it's 0, it's plus or minus 0, so there's only one solution.
And then the determinant is 0.
The formula for the discriminant is in the IB booklet.
These are your two favorite.
I've given you an IB folder.
Yes. It's over.
It's somewhere.
It's called the discriminant.
The discriminant, yes. Hopefully you. Oh, they're using a delta for that. That's interesting. That's how they're representing the discriminant. I've never seen that.
Okay.
I've also never seen anybody write discriminant other than as a word. So the imaginary unit I equals -1.
Yeah. Square root of 8.
Square root of -1, meaning I squared equals -1. And the complex number is a plus bi, where a and b are real numbers. This notation is going to come up a lot. You just have to get used to it. It's not that hard. A and B exist in the real numbers, or A and B are members of the real numbers, meaning A and B are real numbers, is all that means.
Yeah.
The other
It's
one,
bi, that's what makes this.
it's a real number times I, yeah. This, remember, is integers.
They're I times I.
You're gonna see this for complex numbers.
Yeah.
Yep,
For-
so that's what they are. Time to start getting used to them. So now we're gonna write this in terms of I, and this will have imaginary solutions. -6 plus or minus the square root of 36 minus 4 times 1 times 25 over 2 times 1. -6 plus or minus 36 minus 100 is 64. Well, that's a nice one.
Yeah, isn't it sweet 8i?
Yes, plus or minus 8i
Two.
over 2. So -3 plus or minus 4i. Always make sure you reduce this 2 from all 3 of them. That's just for reminder's sake. I'm like, I know you know that, but
Sweet.
yeah. This one, same thing, but we need to set it equal to 0 first. Um, plus 50. That's my problem. I need to. Sometimes I have a challenge of trying to skip too many steps. It's like, this isn't going to be imaginary. Yeah. It's probably a good habit. You just need to be able to do it quickly because the exams go fast. It's amazing how fast 2 hours goes when the problems are hard. -14 plus or minus square root of.
Teachers take it easy. Let's see how they do.
I did.
Really?
Yeah.
Should do again?
I took the mock exams. I did not take the real ones. I probably will this year. Because they're ordering them. We are going to have last year's students' exams. 196 minus
It's not on seven.
or AC.
I'm just wondering how hard it is to get sixes and such.
Especially their master.
I think I barely got a 7. No, I didn't do it.
Teachers should be getting sevens.
I didn't get it. I didn't do it in the time. I think I could have done better on paper 3 had I taken a full hour instead of doing it interrupted. And like, I did some interrupted and stuff like that. So I probably could have gotten in the low 80s.
Teachers should be getting sevens in the respective subjects to be teaching the class
Well,
and expecting us to get good grades.
it was like, poor Mrs. Hatch is teaching it because that's.
But she took them, she took like a mock one and she still got like a 5. And she
Okay.
they just learned that 3 months over the summer, so I feel good about that.
Yeah, I was like,
I mean, it could be better.
yeah, that's -4.
It almost was it. I almost forgot. So.
Yeah. Square root of -4 over 2. Oh, this is going to be a nice one too.
Memorization.
Plus or minus 2i over 2
Set minus.
I. Okay. You know about complex conjugates, correct? Where it's the same thing but opposites.
Plus minus.
Yeah, you cancel the middle term and the n becomes an I squared. So no, it doesn't even have it yet. So simplify the following. I squared.
No.
-1, I cubed, -I. Uh-huh. 1. Because this is I squared times I squared, which is -1 times -1. So, okay. This form, this means real part of Z. They use Z a lot for complex numbers. And imaginary part 3 and -2. So challenging. Really, that example is about learning what the notation means. You're like, yes, I just have to learn some notation. Okay, consider this complex number where x and y are real. Find the values of x and y if the real part equals 2 and the imaginary part equals 9. Okay, so
Have to simplify it down to that like two term.
3xi is going to be 9
Okay.
because that's the only part with an I. So x equals 3.
Two.
Yeah, well, I guess it'd be 9i. Y squared plus 1 equals 2. So y equals plus or -1. Does it give me, all it says is they're real, so that should be good.
Easy.
Yeah, okay. Notice what I did there at the end, though, where I went back to check if there were any other restrictions. Because I wanted to see, is it just one of these? Multiplication of complex numbers. Find A and B if, oh. So you know when you multiply, you FOIL, and then you change the I squareds back to -1. This is really kind of a division problem.
They all speak different.
To solve for A plus BI.
Oh, I see what this is. Man, I should write this one.
No. No. Oh.
Okay, fine.
Divide by the complex number, and you're treating it just like it's a number, or it's like a set of parentheses.
With your house. Slap you around. We pick up. Radio. You can stay in the engine.
Now, how do I rationalize? The denominator. And hopefully algebra 2, I'm sure you did this.
Yeah.
Like, I'm pretty sure Mr. Klein might have given you the same worksheet I'm giving today. 8 plus 12i. Actually, I don't think I gave that in pre-calc. I think that's from algebra 2. Plus 14. Oh, the polar coordinate one is pre-calc, yeah. 21i squared over bottom 4 minus 6i plus 6i minus 9i squared. I squareds become negatives. So -9i squared is +9, and I can cancel those. 8 minus 21 is -13 plus 26i over 13.
We used to use the radio.
Oh, there's no minus there. B is 2. So I must finish the question by actually saying A equals. I just added a plus or minus when I'm thinking I was solving a quadratic and I wasn't. There was no minus in the problem.
So we know that A equals -1, and B equals 2.
Yeah, man, they made that harder than I did. I suppose they did a system of equations that's not really that hard. 2A plus 3B equals 4. So they separated the real and imaginary parts and did that. Division, same idea. I'm actually going to show you this one. You know how to divide, just like we did above with the complex conjugate.
So I just multiplied the top and the bottom by 1 minus 3.
Yes. Now let's show you how to do it on the calculator. Because it can't. We just need to look at which one. 1 minus 2i over 1 plus 3i. And a lot of times, yes, I would totally be working in a scratch pad, but this just automatically wants to open a document, so I went with what the heck, why not?
Yeah, it's fine.
I don't need this in it.
Wait, what's the document just like it saves it?
You can save it. There's more options when you're in documents. So there's a spreadsheet.
I'm just not gonna worry about this.
You don't have, yeah, you don't really need to worry about it for now.
We changed sometimes.
But in the documents, there's a spreadsheet. There's when you do regression, you have to do it in documents. But 1 plus 2. The I button here is next to the pi.
Oh,
So down by the keyboard on the side.
uh, so I can actually just take this
You
in.
can literally type this in. I'm going to show you a few cool things here. That's 1 minus 2i. Well, you might have to do it with variables.
Oh, okay.
So you got to know how to do it by hand because they might give you variables. If they give you this, you just did the division for you.
Wait.
It was 1 minus 2i.
Oh,
I had a typo. Do you remember how to copy and paste? Highlight Control C, Control V for anybody in the future watching this.
I just scroll up and then
Scroll up. Control C.
So you can.
Oh, you can just hit enter.
if you just go like that and then go enter. I think that's easier.
That work. Okay, that'll work, I guess, for this. That might be a new thing. If you want to do it mid-problem, though, you can do Control C and just put it in wherever you want. Or you can copy it and put it in a graph.
It's the V though. Got it.
Now watch this. So remember making polar form last year. We'll go through how to do it by hand. We'll go through how to do it by hand later. Menu, number, complex number tools is the bottom one. I just scrolled up to go around. It does scroll around. Convert to polar. Where?
So I could just.
I have to have the number there, I guess. Menu, number.
Oh, I think that's just because you're in a document. Because it's got answer.
Oh, mine did not pull the answer. A lot of them cited that. This is actually Euler form, which is equivalent to polar.
I don't know.
-1 minus 1/2 I. Oh, yours came out. Okay. So yours came out an angle.
Oh, I have it on degree.
You have it in degree. Oh, that's why.
I couldn't figure out how to get it to change from degrees to radians, and I was doing a problem. and I
Click
couldn't
there.
Convert to radians.
You just click up here. Oh,
Oh,
that's interesting. Okay, so in radian mode, it
see,
puts it in Euler. It's super easy. Let's see. I'm going to try this again.
I was.
Oh, that's sweet. I didn't know that.
If you change degrees.
If you change it to degrees, it gives you, this is radius, that's angle. Now, Euler, I just know how to convert. This is radius, that's angle in radians. In radians, yep. Sick. This calculator is better than I knew.
I don't know what this means.
Well, you remember radius today. So we need to talk about graphing first.
This is a polar coordinate.
That's the polar coordinate, yep.
I don't really know what Euler form is.
You'll learn that one day.
It's just some numbers. Well, e to this.
Yeah.
I don't really like.
So okay. A complex plane. This is known as the Argand plane.
Oh, that was on the thing. I lost points on it because I didn't know what an organ was.
So the one that was on there, 3 plus 3i. This is the real axis.
Well, I'm
This is the I-axis.
stupid. I should have gone.
Well, you will in the future because
An organ plane was.
yeah, that's what people, a lot of people get that wrong because they forget the name.
Yeah.
So let's do another color and let's do a different problem. -3 plus 4i. I go to -3 on the real axis. It's essentially, this is the coordinate, -3, 4. And these become a very helpful way. You can do a lot of vector things with these. There's a couple ways to deal with some of the stuff. Sometimes it's easier through complex numbers. That problem, I did it with vectors. They do it with complex numbers.
That's cool. It's coming in.
And I think it was just a transformation.
Everything's going well. Anthony. Nothing's been for 2 years.
Like you don't write the coordinates in parentheses for the argan, you just do.
You write, you
real
literally,
plus imaginary.
Yep. So that easy enough? For two complex numbers, Z and W. What does star mean?
And it doesn't do like absolute value, like if you're negative on what would be the imaginary axis, you'd put -4.
Mhm. I have to look at what they mean by this. I don't. So I think star is to unknown hour. I don't know what they're meaning by that. So what they're showing here is you can rearrange inside, correct?
Side parentheses.
Mm-hmm.
Oh, yeah. I'm gonna try and keep it.
I see a lot of variables and I just don't want to look at it.
Yeah, I'm really having a hard time with.
No, it makes sense because it's not, it's all additions, so like really some of those parentheses don't really even need to be there.
Yeah. But they'll put parentheses to indicate that this is a single number. So, yeah. They're gonna put the parentheses here. I don't know what the stars are about. Because that's not to a power. they just dropped the to the power part, so.
No, there's like this seems. Then
Yeah,
they do a
that's-
second one and they factor it out.
So that's supposed to be this side versus left-hand side. LHS is left-hand side. RHS is right-hand side. And they're just showing it with various numbers with pluses and minus, I guess. I'm still not sure what the star is about. Unless there's something up here about it. Oh. Oh, okay. Oh, what they're showing. Star is complex conjugate. So the complex conjugate of this is equal to adding the two complex conjugates together separately. So we've got A plus BI and C plus DI, and we get A plus C plus B plus DI gives me the conjugate of it is switch the sign in the middle. If you take the two conjugates, you get A plus C, you get the two minuses, you factor out the minus and the I.
Like 70% makes sense.
So
It made more sense before I knew what the stars were.
So you're looking at this, right? And then the last step, they take the conjugate.
Yeah.
Now they're starting with the conjugates of those,
Yeah.
and then you
get back to what
you get back to the conjugate again.
Okay.
That's notation that I apparently didn't remember from the last time I taught this. Okay, this one. This is where it gets a little harder. Solve the system of equations. Z and W are both complex numbers. So I think what I want to do is solve for W and plug in here.
It's fun.
Actually, no, let's not do it that way. Let's divide by I first. So I'm going to take the top equation. I'm going to divide both sides by I.
Maybe after.
I will get rid of the I in the denominator. This will make my life easier, actually, by multiplying by I over I. Giving me ZI plus 2I squared over I squared, which is -1. Actually, let's just make it I squared.
I will call it. I will.
So then ZI minus 2 over -1. I'll get rid of this negative by bringing it to the top. And now I no longer have a fraction.
C5 plus 2 plus
And remember the plans. Flashback.
Okay.
I guess I'm gonna clear out some space. Thank you.
Do that.
I want this. Now I'm gonna plug that into W in the bottom equation.
Okay.
So this is
So.
systems of equations, like you've been learning since middle school. But more complicated version.
There's 3 tiers.
And I'm going to now distribute.
The point. Exactly.
I guess I have to distribute this one twice. No. It's 2Z. I'm ahead of myself. I guess I'm gonna gather all the C's to
7 and 4.
yes. So I'm gonna gather all the Z's to that side. And so I've got -2 minus 7i equals 2Z minus 3ZI.
Fine. Keeping, oh, we're just taking all the Z's to us.
I'm taking the Z's to one side, not the I's. And then I will factor out a Z. That skill of gathering all my variables to one side and factoring it out is going to come in useful a lot. We did it some in pre-calc, but probably not enough.
That was the Eastern.
And then I will divide by the 2 minus 3i, conjugate it, giving myself -4 minus 14i minus 6i plus 21i squared over 4 minus 9i squared. So this time I did not put my middle terms in on the bottom. This is now +9, this is minus 21. Giving me -25 minus 20i over 13. I'm gonna check that answer. We're not done here because we still have to find W, but I'm gonna check my answer before we find W.
Same thing.
But negative 25 minus 20i over 13 is equal to z times 2 minus 3i, right?
No, it's just equal to z.
Oh.
But that's not. No, z is supposed to be 1 minus 2i.
And we'll say
Okay, what happened here? What did they do? They solved the top one for z instead of for w. Plugged in for both the z's. Where did I? I'm not sure where I made my mistake, but I made a mistake in there. Let's see here.
That's
7i z minus 1 equals 2 z plus 2 zi plus 1.
there's no push, no, man. So it's nice.
3i minus w. To make sure I solved this first one correctly. Three I minus W.
Is dat heel lastig? Or
I don't know how I got that first answer. I plugged in the wrong thing. Right process this wrong thing.
wait, the first answer for w is wrong?
Yeah, because I'm looking at this going, how did I get W equals ZI plus 1? Z, so I've got Z plus 2I
Says it's still good.
equal, yeah, 3I minus WI. Oh, no, maybe it's not. So I subtract 3I and I get Z minus I equals negative WI divided by negative I. And when I multiply by I over I get ZI minus I squared over negative I squared. The negative equals ZI plus 1 over 1. Oh yeah, no, that was right. I did get that right.
there's gonna be minus 7.
CI plus 1 minus 7i plus 2. Oh, this was a 4. That needed to be a 4. Yeah, so I get something different when I multiplied it out. So that's the process. Polar coordinates, quickly. Polar coordinates should be pretty easy, but share a whiteboard.
Are we doing polar coordinates?
Yeah. Polar coordinates are simply you measure a radius and an angle. Like in trigonometry, so if I've got 475 degrees, positive angles That's radius and that. I've got something like -3. Oh, let's do positive. 3 negative 125 degrees. I get that.
And we're always doing the same, like.
Counterclockwise for positive, clockwise for negative. I have negative 360 degrees. 360 would be here. So it is actually a radius of 3. It's at 180 degrees. A negative radius is just straight opposite direction of where the positive one would be. So this ends up being at negative 360.
But you put the angle like, is it straight across, you know,
Mhm.
like it's on the.
Yeah, it's this the 60 here. If it's ne-
60 well, okay, I don't know.
This is a 60 here. You could say it's off the negative x-axis. Yeah.
Get the wrong.
So yes, I did go, it's exactly 180. If you went off the negative x-axis, that would be a way of thinking of it too. Converting polar to rectangular is very easy.
You just have to do some.
Sine and cosine. So cosine of 75 equals x over 4. It always works out if you measure it properly. R cosine of your angle will give you your x, and R sine of your angle will give you your y. X.
Good measurement for your radius.
If you don't know the radius, it's not going to work. But that would convert between polar and Cartesian coordinates. And R sine theta. Make sense? Okay, that's it for today.